Welcome to day 36 of our course on object-oriented programming. In today's lesson, we will be diving into unit testing using Python's built-in framework, Unit Test. Today, we will cover key concepts in testing, including why it's important and how to write effective test cases. Before we begin, let's understand what testing is. Testing ensures that software works as expected. There are several types of testing in software development. Unit testing, which tests individual functions. Integration testing, which focuses on how different components work together. System testing, which tests the entire application. And finally, acceptance testing, which verifies that the software meets business requirements. Testing is crucial for several reasons. It helps identify bugs early in the development process, ensuring that the code behaves as expected. It also helps maintain code quality, especially when refactoring, and ensures the long-term stability and reliability of the software. Unit testing provides numerous benefits. It allows you to catch bugs early before they become big issues. It ensures that individual parts of your code are working as expected, which is key for long-term software quality. Unit tests also make it easier to refactor your code, knowing that any breakages will be immediately flagged. In Python, we use the unit test framework for writing unit tests. The basic structure of a test case is to subclass unit test, test case, and define methods that start with a word test. These methods contain assertions that check whether the code works as expected. Let's look at a simple example. We have a function add a comma b that adds the sum of two numbers, that returns the sum of two numbers. We write a test case in a class that subclasses unit test. Test case. The test add method contains assertions like self.assert equal add 1, 2, 3, which checks if the result of add 1, 2 is indeed 3. Unit test provides several built-in assertions to check conditions. Assert equal a comma b checks if a equals b. There's also assert not equal a comma b to check if two values are not equal. Assert true x and assert false x to check boolean values, and assert raises to ensure that a certain exception is raised during execution. Writing test cases. When writing test cases, it's important to ensure that they are clear, independent, and focused on one specific aspect of the function. Method names should describe the test purpose clearly, like test addition of two numbers, so anyone reviewing the code can easily understand the test's intent. Here's another example. Consider a function subtract a comma b that returns the difference between two numbers. The test subtract method contains several test cases, including subtraction, subtracting positive numbers, negative numbers, and edge cases like subtracting 0 from 0. To run your unit tests, simply use the following commands in your terminal. Python -m unit test module.py. This will execute the tests defined in test module.py and provide you with a report on the success or failure of each test. There are several best practices to keep in mind. One is test-driven development, where you write tests before writing the actual code. Tests should be independent of each other to avoid dependencies. Additionally, mocking is a technique used to simulate parts of the system that are not the focus of the test, ensuring that tests are isolated. Now it's time for some hands-on practice. Your first task is to write test cases for a function that checks if a number is prime. The function called the function should be called isPrimeN. Be sure to test edge cases like 0, 1 and negative numbers, as well as prime and non-prime numbers. For the second task, write test cases for a function reverse string s. This function should reverse the given string. Test cases should cover scenarios like empty strings, single character strings, and multi-character strings. To summarize, today we covered the basics of unit testing, the importance of writing tests, and how to use Python's unit test framework. We also looked at common assertions and best practices. Remember, testing is an ongoing process, and writing effective tests ensures your code is robust and maintainable. Before we conclude, here are some additional resources for you to explore. The official Python unit test documentation is a great place to start, and if you are interested in test-driven development, the book Test-Driven Development by Kent Beck is highly recommended. You can also explore other testing frameworks like PyTest and Nose for more advanced testing techniques.